Good morning, friends. In this segment, we'll discuss about another important topic from digital signal processing or mathematics, which is known as Z-transform. Now, friends, before starting with Z-transform, first we'll discuss about what is meant by transform. So, as you know that transform is a technique by which we convert a signal from time domain to frequency domain. Maybe in case of Z-transform, if a signal is discrete, which is x of n, it is converted into frequency domain as x of z. This is simply the notations. Now this method is used so as to analyze signals or maybe the systems in frequency domain, because it is quite easy to analyze every system in frequency domain in comparison with the time domain. Now there are several techniques for doing it. We can have Fourier series, Fourier transform, Laplace transform, or Z transform. Now, what actually mean by Z transform? So basically, Z transform is used to represent complex exponential functions. Now, if it is a complex exponential function, in general, we'll define Z is equals to R into e raised to j omega. Now, this R is nothing but radius, we can say, and this is exponential function. So if I simplify this, I can write this term as R into cos omega plus j into sine omega. That means it is a complex exponential function, as well as we are having a complex number as cos omega plus j sine omega. So they are used to represent these complex functions. Now next term, Z transform can be obtained, or equation for Z transform can be obtained from a technique that we already discussed, that is known as discrete time Fourier transform. So let us take help of discrete time Fourier transform and we'll come across Z transform. Now basically discrete time Fourier transform of x of n, we generally denote this as x of e raised to j omega is equal to, we are having summation from minus to plus infinity. This is my input signal x1 into e raised to minus j omega n. Now we'll replace the value e raised to j omega with z. Now to do this, we can assume let r is equal to 1. That means radius is equals to 1, so that it becomes a unit circle, and we can get z, I'm writing it here as e raised to j omega. So if I replace this value in this equation, we'll get this equation as xz is equals to summation from minus to plus infinity. This is x of n. Now this e raised to minus j omega is nothing but z. That means I can write z raised to minus n. So this is the simplest equation for Z transform of input sequence as x of n. If you see the length is from minus to plus infinity, that means we can simply assume this is a bilateral Z transform. Now this is known as bilateral Z transform because it has both the limits. It has a negative side as well as positive side. So it is known as bilateral Z transform. Now in many of the cases they asked us to find unilateral Z transform. So it can be right sided or left sided. So for right sided, it should be from 0 to plus infinity xn into z raised to minus n. This is unilateral Z transform, and this is for causal signal. Causal means we can say it is a right sided also, and if it is left sided, the limit changes from minus infinity to minus 1 xn into z raised to minus 1. So it can be a unilateral Z transform for left sided signal. Now this is the equation for Z transform. Now coming to the part of how to obtain inverse Z transform. So again we'll take help of inverse discrete time Fourier transform. In earlier case it was dt of t. Now we'll take inverse discrete time Fourier transform of x e raised to j omega is. So we are having that equation xn is equals to 1 upon 2 pi integration. Typically I am taking this value minus plus infinity. Input is now x e raised to j omega into e raised to plus j omega n into d omega. Now we'll try to replace the value of exponential function with z. So we'll write let z is equals to e to the power j omega. Now we need some d omega over here, so we can differentiate on both the side with respect to that term. So we'll get dz is equals to e raised to j omega into this part j omega becomes j into differentiation of omega is simply we can call it as 1. So it becomes dz is equals to this part. So I can replace the value of d omega as like that terms. So we can write d omega is equals to, this goes to the denominator, so we will get dz divided by j. Instead of e to the power j omega, I can write this value of z, that is nothing but z. That means every term we are represented in the form of z. So this equation holds xn as 1 upon 2 pi. Now that integration minus 2 plus infinity. Next term, this is our x of z into e raised to j omega is nothing but z raised to n into d omega is dz divided by j into z. Now this z is in denominator, so if I replace it or if I convert this into the numerator terms, we'll hold this equation 1 by 2 pi integration x of z into z raised to n into z raised to minus 1 into dz. Now here the base is same, so we can add the power terms. So from that we can get inverse Z transform equation as xn is equals to that j is remained, so you can take j over here. So this is 1 upon 2 pi j integration xz into z raised to n minus 1 into dz. So this equation is known as inverse Z transform. Now we got both these equations, the equation for Z transform as well as for inverse Z transform. Now the next and important part that we will discuss is known as ROC, that is nothing but region of convergence. This is region of convergence. Now as far as Z transform is considered, or even for Laplace transform also, region of convergence simply indicates the value of the given term which is less than infinity. Now if I write this equation again, that is xz is equals to summation n minus 2 plus xn into z raised to minus n. Now the important condition is what? We have to find all the values of z for which x of z will be finite. That means its magnitude will be less than infinity. So the important condition will be mod xz should be less than or equals to infinity. So if this condition is satisfied, one can say that the system is going to be stable, and hence from that we can write the definition of ROC as it is set of all possible values of z for which xz becomes finite, for which x of z becomes finite, and that term is known as region of convergence. Now as far as the possibilities are considered, so by this equation we can say we can have unilateral transform for left sided as well as for right sided sequence. So if I consider for right sided sequence it is greater than, and for left sided sequence it should be less than, and based on that one can say that region of convergence can be drawn for Z transform with respect to a unit circle, because we are considering radius as 1. So by that way every time we can draw the region of convergence by considering typical value of radius as 1. So this is our real terms, and here we'll write the imaginary terms, and this is the circle whose radius we are considering, let r is equals to 1. Now there are three possibilities. One, the region of convergence can be exterior part of the circle, or region of convergence can be interior part of the circle, and if I assume different pole points it can be in between that. So for that case always remember one thing: if signal, that is input signal, is causal, ROC will be greater than pole points. If it is anti-causal, that is left sided, ROC will be less than the given pole points. And third possibility, if it is both sided, ROC will be greater than positives and maybe less than the negative points. So based on that, one can draw the region of convergence. Now we'll see some examples on this, and we'll try to realize or try to obtain the region of convergence also. So let us see this example. Here we have to find Z transform of X of n, as well as we have to mention ROC. So straight away, first step, we'll write Z transform is equal to xn into z raised to minus n. So we'll put those values. This is minus to plus infinity a raised to n multiplied with u of n into z raised to minus n. Now this input signal is multiplied with u of n. U of n is nothing but unit step sequence, and it will have constant value, that is, it will have an amplitude 1 for all positive values up to infinity. This is going to be 1. That means if I multiply this signal with a raised to n, it will have a value of a raised to n starting from 0 to infinity, and hence it is known as right sided sequence also. So based on that, this limit will change, and now it will be from 0 to infinity. Remember this term, whenever any signal is multiplied with u of n, the limit will change from 0 to infinity, it is right sided, and if it is u of minus n minus 1, it will be from minus infinity to minus 1. This is a raised to n, and in this limit 0 to infinity, its amplitude is 1 into z raised to minus n. So we'll write this again. This is 0 to infinity a raised to n into z raised to minus n. Now to simplify this, we can take n as common from both the terms, that is in powers. So this equation holds 0 to infinity a z inverse raised to n. Now we'll apply a formula for summation that is given by, this is the standard formula that one should have to remember. 0 to infinity a raised to n should always equals to 1 upon 1 minus a. Here we are having this entire term as a, so this equations or this value becomes 1 divided by 1 minus a into z inverse. That is nothing but, we can write xz is equals to 1 divided by 1 minus a into z inverse. If I simplify this, we can write 1 minus a by z, that becomes z divided by z minus a. So this is our Z transform for the given function. Now we'll come across finding the value of ROC. Now to find the value of ROC, always try to check whether the signal is right sided or left sided. Now if you see this signal is multiplied with u of n, that means it is a right sided sequence. Now if it is right sided, definitely your ROC should be greater than the pole point. So we'll find the pole points. Pole points can be obtained by equating denominator terms to 0. So here the denominator is z minus a, we'll equate it to 0. Z minus a is 0, so z is equals to plus a. That means plus a is your pole point. Even if you put this value here, a minus a will be 0. Anything divided by 0 will be infinity. That means your ROC exists everywhere except at z is equals to a. And by that, now we'll draw its region of convergence. Here it is. We'll draw a circle. Let these are my pole points. This side will take a, this side minus a, and our ROC should be greater than this pole point. So here this becomes our region of convergence. So you can see ROC is greater than mod a. Mod a because it will have both the values, if you have negative or positive. This is a real part and this is our imaginary part. So this is Z transform of a raised to n into u of n.